So, I'm just going to clear up kind of what was happening in the last video. What it was an experiment with microwaves, and what I did, I had what we call a magnetron, and I was running it, and I'm not 100% sure if it was actually running or not, but I'm pretty sure it was running. And I was just trying to see if I could warm up some water and a wet paper towel with it, and I couldn't feel any difference in the temperature, but that might have been because either it wasn't actually working or because it just didn't make enough of a difference in temperature, because either the water was too cold or maybe the signal or the microwaves were being too dispersed and not focused enough. But so that was my last experiment from my last video that I posted, and I don't know, I'm going to be doing more videos on that and trying to see if I can get the microwaves working and try to get some actual tests. And I guess now I'll tell you the reason why I'm doing these tests and experiments is because I'm hoping I can get wireless energy transfer with microwaves. And before I get into any more of that, I'll cover that in the later videos. I want to talk about doing that with transistors and coils, and there's plenty of videos on YouTube showing you how that works and what is going on. And this is mine. I just put together, and it's just inside this little Altoids tin, and it runs off a 9-volt battery. There's just inside, I have a potentiometer to adjust the voltage, and a little circuit with a NPN transistor. And I've run it with several different sizes of coils. Here I've got one of these big ones, two smaller ones, like this medium one. But what I found is that the medium ones, they aren't too big, are the best ones for the transfer. And I have, I believe it's 18 or 24 coils, or 20 turns in it, 18 to 24 turns. And that's how I've gotten mine to work. And so I'll just go ahead and demonstrate that with my little circuit. Okay, so here I have my original drawings and circuit of the NPN transistor wireless energy transfer circuit, and my original experiment with it. And it actually took me a pretty long time to get it working, because originally I tried to do it with some 2-strand wire, and you can see that here. I don't know how well it's focusing, but you can see it here that I had an NPN transistor working with 2-strand coils of wire, and I couldn't get the resistance right, and I kept blowing transistors, and I did not get any transfer of energy at all. And so I just decided that it required too much current for it to handle, and there was no way it was able to handle that much current and transfer electricity. So I switched to this single strand wire, and I experimented with it, and the same thing kept happening with my transistors blowing, and so I threw on a little adjustable potentiometer and just tinkered with that until I got one that works. And so I have it here, and it's again just a 9-volt battery, and the power is coming in, and it's being, let me see if I have a schematic of this one. Yes, I do, right here. And so what's happening is the coil has 12 turns, a center tap, and another 12 turns, and there is ground going to the emitter pin of the transistor. Power is going to the potentiometer, which then goes to the center tap of the coil, and one end of the coil goes to the base of the of the transistor, and the other end goes to the collector. And basically what I've done, what I think is going on when it does this is in order to have wireless energy transfer with coils, you need a varying magnetic field, and what that looks like is a magnetic field that's going up and down and up and down over and over and over. And what that does is, as the electricity goes through one coil, it makes that field, which shifts up and down, up and down, up and down, over and over, which then induces a shifting current in the other, which can be rectified with this little diode. And so I'll just turn that on, and I'll show you what that looks like. Let me flip off this light so you can see that a little better. Yeah. This is with the small coils, and so the transfer isn't huge, but it's decent. Stick a box on there. So you see it's actually wireless. And so that's what I had. And so I figure, since this works with the transistor shifting the amount of electricity and therefore shifting the field, I could probably do it with a 555 timer. So I set up this circuit here with a 555 timer to create a frequency, a square wave frequency, and you can adjust that frequency with a potentiometer here, and you just twist it and it gets faster. You twist it the other way, it gets slower eventually. See if I can get that. Actually, it's going faster that way. So I had it going pretty fast, and I had the outputs on a coil, and I was trying to get that to work, and that actually never worked. And I think it's because it just wasn't shifting fast enough, and so I left it at that and decided to move on, because this isn't really what I wanted to do anyway. This is near field, and I was looking for far field, but that was a successful experiment. So, as you saw, my little coils can transfer a little bit of energy, and so just to wrap that up, I can get, it's probably less than a volt across, up to 3 to 6 inches at most. That's really pushing it. So what I've decided to move on to next was the the microwaves, and that's where you saw my previous video coming from. And so all I'm trying to do there is use dipole antennas to transfer a ton of electricity. I'm trying to get more than just a few volts, and I'm trying to transfer it over more than a few feet at least, is what I'm looking for. And so I'm just going to use household microwaves and some dipole antennas made out of copper wire. I'm going to see how far that gets me. So I guess that's it for today's video. I'll see you sometime in the future.